collaborated with various environmental industries for the field projects. He has chaired a technical session in International Conference Recycle 2020 at IIT Guwahati, organized by Waste Management Research Group. Dr. Jain has taught more than 5 different courses at all levels, including UG and PG. He has guided 3 PG level projects and currently supervising 4 more such projects at NICMAR Pune. So we are very fortunate that we have got a very qualified faculty uh, delivering the lecture on the solid waste management, that is the composting. So I welcome you, Dr. Jain.
Yes, thank you, sir. Thank you, sir. And thank you for this wonderful introduction of me. So shall I start, sir?
Yes, yes, you can start.
Yes, okay. So I'm really thankful to Professor Singh and Dr. Professor Jha for this wonderful platform to interact with different participants from the different part of this country. So it's really fortunate for me to showcase my research study as well as what we are doing in terms of the solid waste management. So I'll start with my presentation. Although Professor Singh already have introduced me in terms of what we are doing, but let me give you brief about my journey. Okay, so I'm Mayur Shirish Jain, assistant professor at National Institute of Construction Management and Research, Pune. My journey started in 2007. I have done my BTech in civil engineering from RTM Nagpur University, MTech in civil engineering, environmental engineering from Sardar Vallabhbhai National Institute of Technology, Surat in 2013. I have 1 year of industrial experience, 1 year of teaching experience before PhD. I have completed my PhD in civil engineering from Indian Institute of Technology, Guwahati, where my most of the work we have carried out in solid waste management. And after that, in 2019, I have joined particular this NICMAR Institute as an assistant professor grade 1. And there my responsibility is to focus on research and teaching. I also received a title from Institute of Engineers India, that is Chartered Engineer. These are some of the research areas where we have focused, that is solid waste management, environment management, EIA, LCA, techno-economic assessment, and sustainable development. And these are some of the ongoing research projects: cost benefit analysis of waste management, implication of the C&D waste, transforming existing building into green building, as well as we are also focusing on sustainable construction materials. So anyone are willing to know about my research, they can go through Google Scholar citations and you will find different studies which I have published so far. These are some of the known studies, peer-reviewed journal, Waste Management, in Journal of Environmental Management, Journal of Cleaner Production, which are these studies are mostly focused on solid waste management, basically in organic waste management. Anyone wants to connect with me, they can connect with me on LinkedIn or via ResearchGate. These are some of the awards that I have received so far in terms of whatever the work we are doing. These are the recognition. Already Professor Singh have discussed about my profile about the recognitions. Okay, so coming to today's session, that is today's topic, we'll be focusing on the decentralized composting of organic waste. So there are a lot of things in terms of organic waste, a lot of issues, a lot of challenges in terms of how the organic waste are managed in India. As we know that most of the waste we are directing to the landfill sites. Again, these landfills are also one of the major concern for most of the people or most of the scientists or researchers in India. So because these landfills create a lot of problem in terms of methane gas or in terms of the leachate production. So these are the different things we are going to see. So these are the contents, that is introduction, impact of COVID-19, what is solid waste, different sources and types. I think although you have gone through these sources and types in the previous sessions with the waste management, but still I'll just give an introductory thing about sources and types. Some statistical thing in terms of what is the current situation of the different waste, what are the types are there in terms of the waste, what is the composting, what is meant by composting, what are the different factors that are affecting composting, what are the different types of the composting method. We'll also go through some of the videos, some of the equipments that are generally used at a large scale, or maybe at a small scale, or maybe at a lab scale. So we'll go through all those small videos. Then what are the design consideration in terms of if you want to go for a composting in a particular society or in a particular residential area. So what are the design considerations that we'll also see. There are a few case studies, maybe 3-4 case studies I have with me, and we are going to discuss on those case studies how the composting can help us in terms of managing the organic waste within the society. So nowadays we can say that decentralized management of organic waste is a new trend coming up in every city according to the according to the solid waste management rules 2016. So again, it is a mandatory thing that if we are generating more than 100 kg of waste, so that we will that we have to manage within our society, right? So this is what different case studies are there that we'll see, and what are the opportunities are there in terms of the organic waste management in India. Okay. So I'll rather start with instead of talking about the solid waste management, we'll initially start with some different aspects. That is one of the aspect is earth is healing. This is what I have read somewhere in 2020, maybe during the lockdown period, that earth is healing. So I have doubt about earth is healing, whether really we can say that earth is healing, because we are largely dependent on many natural resources in terms of our food, water, or various different things. At the same time, we are also generating a lot of waste in terms of solid waste, in terms of liquid waste. At the same time, we are disposing it without having any treatment. So we are largely dependent on various sources. And during the COVID-19, we have observed that all those natural bodies, all those natural resources got maybe reduced. What are the different problems related to the air pollution, related to the noise pollution, related to the water pollution, maybe got reduced during that period. But still, the problem, the real challenge, the real problem of the different natural bodies, maybe air or water, are still there, that we are going to discuss in the subsequent slides. So coming to the improvement in the air quality, yes, we have observed that there was a improvement in air quality maybe in the last year. As we know that our capital is ranked as the most polluted city in the world by WHO in 2014. The air quality index generally goes from 200 to 400, right? And but during the COVID situation, we have observed that yes, the Delhi have observed the reduction in the air pollutants, whether that is related to the PM 2.5 or PM 10. Okay, so this is what we can say, that yes, COVID-19 at least helped us in terms of reducing the air pollution. Coming to the some animals or some aquatic animals, you can say that they came to the surface maybe because of the reduced pollution in terms of whatever we pollute due to the industrial pollution, or whatever the different problems or illegal disposal of the waste into the liquid into the ocean bodies or aquatic bodies. So this is also helped us in terms of managing the water pollution. The number of flamingos increased in Mumbai as a result of the lockdown imposed due to COVID-19. Tens of thousands of flamingos have gathered in the city of Navi Mumbai, and it's a very, fortunate thing for all of us that we have observed such kind of a natural, maybe you can say the animals, or which are birds, or which are of national importance, right? So these are some of the important things that maybe we have observed in the recent period. Even the ULBs have also discussed about Ganga is now fit for drinking in Haridwar. So during the lockdown period, only for 2 months, they have done the testing, and they have observed the pollution of this Ganga river got drastically reduced, right? So this is what maybe we can say we got some benefit in terms of COVID-19. No doubt, it has affected many lives in terms of the health, but in terms of the natural bodies or environmental bodies, we got some maybe you can say some benefits, right? But what about solid waste? I mean, it's very important to understand here that although the different bodies, maybe air body or maybe the water bodies got benefited with the COVID-19, but what about the solid waste? Whether it is got benefited? No, the answer is no, because you can see that this type of biomedical waste are generated from most of the hospitals and various places, or maybe various clinics, right? And the situation is not only in India. I mean, never blame our country in terms of the solid waste, but all the countries, if you talk about USA, because this picture indicates that, I mean, this picture is from the different scenarios from the different countries. So you can say that, okay, all the countries have some problem in terms of the solid waste management, and what actually they are doing, that is what we have to focus, right? So biomedical waste is one of the waste, maybe we can say it's creating a lot of impacts in terms of whatever the environmental problem we are facing, right? So we can also say that threat is not yet gone in terms of the waste management or the waste pollution, right? So you can say that the threat is still there. People around the world are taking a lot of precaution in terms of they are, consuming a lot of pharmaceutical, they are using sanitizers, they are using gloves and all those different materials. But at the same time, we are also disposing these waste in the open dump site, in the open areas, right? And ultimately it will cause some kind of a contamination or pollution to most of the people. So that is why we can say that the threat is still there, although we have faced a lot of issues in terms of whatever the COVID-19 is concerned. So what is waste? So I think most of you are already aware about the definition of the waste. A waste can be defined as any material which has no longer values and has been discarded or discharged by the original owner or user. So nowadays, if you see that we have a with the state, with the change in the standard of living, we go for purchasing 2 mobiles or 3 mobiles, right? Some people are having 2 laptops as well. So this is what our tendency is, and this is why we can say that the solid waste is continuously increasing. And once the things I mean, their utility is over, the product utility is over, we generally dump it into the landfill site, or we dump it into the open dump site. So this is what maybe we can say the solid waste is continuously increasing, right? Any discarded, rejected, abandoned, unwanted, or surplus matter, whether or not intended for sale or for recycling, reprocessing, recovery, or purification by separate operation from that which produced the matter. So this is one of the definition given by EPA in 1993. So any discarded, rejected material which is of not useful for an individual will be in general considered as a waste. Okay, and if you go in various places, you will see the different definitions for the waste, but in general it is nothing but the discarded, rejected, or abandoned product. Now coming to the situation of India in terms of the waste, you can see the this is a landfill site. A small boy is also working there on the landfill site as a rag picker, and maybe you can say this is the situation of most of the uh, you know uh, uh, the poor people in terms of for their bread and butter, and that again it is impacting in terms of whatever the health problems are concerned. So we have personally visited during my research at IIT Guwahati. We have personally visited one of the landfill in Guwahati, that is Boragaon landfill, and we have interviewed some of those people, those who were living in the same area, nearby area. So we have observed that these pickers are extremely maybe you can say living in a worst condition in terms of the leachate, I mean the water they are drinking have a leachate contains have amount of BOD amount or COD amount more than 50,000 or 70,000 mg per liter. So this is what maybe we can say that rag pickers are facing a lot of issues in terms of health. And again, you see the landfill site, we do not have a proper sanitary landfill site. Most of the landfill sites are kind of open dump sites which are unhygienic conditions, and most of the waste you can see again in an unsegregated manner, right? So that is again maybe we can say one of the biggest challenge for all of us in terms of managing the solid waste. Coming to another scenario, you can see that most of the animals are also getting some food from those waste, and ultimately it is impacting those animals. At the same time, we consume milk from those animals, so we'll also get affected with such kind of act whatever we are doing. So most of the people are having tendency to throw the waste not into the dustbin but on the streets, right? So again, that is one of the biggest concern for all of us. Some of the scenario indicates that some people are disposing their waste into this particular water bodies or nalas. At the same time, you can see the another figure on the right side indicates that some of the people are disposing their waste just in the backyard. So this is what maybe we can say in India, or maybe in various places, in small places, or in urban areas or in rural areas, you can see such kind of situation, right? Even this is also one of the scenario from the different place. This is another scenario in terms of how we are reluctant in terms of burning the waste alongside road streets. So this is again one of the problem, because if you burn plastic waste kind of thing, or different other materials, so you will be producing furans and dioxins, which are highly carcinogenic in terms of your health, right? So that is what maybe we can say the situations we are observing everywhere throughout India, and that is what we need to focus, that is what we need to address as immediately as possible. Otherwise their consequences will be very difficult in terms of our health or in terms of our environment. So these are another different photos from the different cities or different areas. This is one of the photo from the Mumbai landfill site. So you can just see that this particular landfill site reached to a height of nearly maybe 10 floors or maybe 8 to 10 floors. So this is again the heap or the hill of these particular different types of landfills are continuously increasing. Okay, so how solid waste also affected us in recent years? So yes, I think most of you are know that Mumbai get a lot of precipitation every year, and most of the times we have also observed the drainage got clogged in terms of the solid waste that we are generating from the different houses, because they are not cleaning maybe, or whatever the population is there, it's very difficult for ULBs as well to manage all those drainage. So again, I will say here that it's a responsibility of an individual to manage their solid waste, right? So this is what the concept is, a decentralized solid waste management. So we have seen a lot of issues in terms of the precipitation in Mumbai, and due to the clogging of the drainage, the flood regularly come in the Mumbai, and you can see the different scenario of a Mumbai area where the construction is also going on and the waste is lying in the water bodies, right? Similarly, we have also seen in Chennai flood. Again, after the flood, most of the plastic came on the on the side of the beach, and you can see that the workers are working to clean that particular beach areas, right? So this is what we have seen in Chennai in last few years, that is in last maybe in 2016 or 18 we have observed such kind of situation. So this is continuously, maybe we can say that solid waste is one of the thing which can be easily we are witnessing easily, but at the same time we are not doing anything for that particular maybe solid waste management. Okay, there are, besides that Mumbai problem and Chennai problem, we also had different issues in terms of the imported scrap from the Iran. So there was a blast in the Bhushan Steel factory at Noida. Reduction in the number of migratory birds due to the consumption of contaminated food. So as you know that we have a open landfill sites. So most of the birds, they are migrating from other countries to India, and also going from India to another country. But there is a reduction in the number of migratory birds due to the consumption of contaminated foods which are there on the landfill sites, right? Stray animal dying on streets and farmland due to consumption of plastic bags which block the food movement in their stomach. So this is also one of the issue in terms of whatever the problems we are observing. Even in 2017 or 18 somewhere, we have also got some article which was indicating about the amount of the gases that are releasing, or the burning is going on burning was going on in this particular Mumbai landfill site, right? So that is what maybe we can say some activities are man-made activities, but sometimes landfill get burn on their own. But most of the times we can say that to get rid of the waste, most of the workers are putting the fire in that particular landfill site, and ultimately it will affect most of the people living in that particular area. So solid waste comprise all the waste arising from human and animal activities that are normally solid and that are discarded as useless or unwanted. It is all inclusive the heterogeneous mass from the urban communities as well as more homogeneous accumulation of agriculture, industrial waste. So refuse, garbage. So these are the different terms we generally give in terms of the different types of waste. So refuse, garbage is generally some kind of a weight waste, rubbish, scrap is generally we talk about the metals, trash is also some amount of metals, litter is something which having some amount of liquid proportion, debris. We also talk about the C&D waste debris. So these are different terms given to the solid waste, and based on the types of the solid waste, we give the different definitions. So what are the sources of the solid waste? I think most of you are again aware about the different sources of the solid waste that are nothing but residential source, commercial source. So residential generally includes householding as well as some amount of garden clippings, yard trimmings also comes from the residential source. Commercial generally includes hostels or hotels. So in which we can say that more amount of food waste will be generated, that is organic waste. Institutional generally includes the school, colleges, then different institutions that will mostly paper and paint, all those type of material will be generating from these places. Construction activities are also responsible for C&D waste. And now if you talk about the C&D waste, right now I am also focusing on the C&D waste. So currently 1% of the C&D waste we are treating in terms of, or we are recycling out of all the 100%, right? So again, that is one of the another maybe you can say issue in terms of solid waste management. Municipal services generally includes the sewage treatment plants or different treatment units where sewage or sludge will be generated at the same time will be utilized for the farming purpose or agriculture purpose. But we have to understand whether those sludge or whether those sewage is really healthy in terms of or having a nutritional quality in terms of whatever we are putting as a fertilizer in the agriculture field or not, right? So that is what again concern we have to think about it. Treatment plant sites, industrial areas are also there, like a lot of industries. We are having textile industry, we are having automobile industry. So a lot of different types of industrial waste are generating. Agriculture residues, as you are again aware about most of the agriculture residues in Punjab, Haryana, in Delhi region, we are most of the times we are burning it and we are not actually utilizing. There are a lot of things that can be done by converting this agriculture waste into the useful product. And no doubt biomedical waste, in the recent period we have observed a lot of issues in terms of the biomedical waste. Now these are generally termed as in a four different options, that is MSW is a municipal solid waste, industrial solid waste includes treatment plant site, municipal sites, and some amount of industrial sites. Agriculture is agriculture waste, and biomedical is considered as a hospital waste. Now coming to different types or different contents in these particular types of waste, so you can see that residential generally generators are the single and multi-family dwellings, generally includes food waste, paper, cardboard. Now when you talk about the food waste, maximum amount of food waste will be generated from the residential, because obviously we consume food, so obviously we are going to generate more amount of food waste. Besides that, we also use lot of hazardous waste in terms of mobile batteries and all other such kind of electronics items that are generally comes under the hazardous waste. Industrial, we can say that heavy manufacturing units, fabrication units will generate housekeeping waste, packaging waste, food waste. Nowadays, if you say the plastic material which is generally nowadays we are using as a packaging material, or maybe the cardboards, nowadays we are using a lot of cardboards in terms of Amazon buying, or maybe Myntra.com. So all those different websites, or maybe the organizations are using packaging material, cardboard or plastic. That is also one of the issue we are we have to think about it. Commercial, again, we can talk about the stores, hotels, restaurant, that includes paper, cardboard, plastics, wood, food waste. Institutional, school, hospital, prisons, paper, cardboard, plastics. Construction, demolition, mostly we will find wood, steel, concrete. So concrete amount is more compared to the wood and steel. Municipal services, street cleaning, landscaping, parks include street sweepings, landscape and tree trimmings. So these are some of the different types, or maybe you can say the different contents from the different sources that we are generally observing in terms of the solid waste management, right? Approximate decomposition time of waste. So I think you know that the organic waste in general, if you won't give any kind of a treatment, it will automatically degenerate within a week or two, right? So that is, maybe you can say that organic waste can be easily decomposable, or maybe it's because of the biodegradable pattern of that particular organic waste. Paper, whereas takes 10 to 30 days, cotton cloth to 5 months, wood 10 to 15 years. So just you have to understand here that whatever the waste is we are generating, so they have a specific time period, and it's really very difficult in terms of whatever the plastic bags is concerned. Now you can see here that it takes nearly 1 million years. So the plastic bag is really a big problem for all of us, and even India recently have reported that we are going to ban the single plastic use. I think we have already banned it as of now in different states. So that is one of the good initiative by the government in terms of managing these plastic bags. But what about the plastic bags which are already there on our earth, right? So maybe we have to think about it. So that is another topic anyway. We are not going to discuss that thing in detail. But yes, organic waste is one of the things that can be decomposed easily in terms of their the period is concerned, right? So a week or two. But whether that decomposition is beneficial for us or not, that is what maybe we have to think, and that is what maybe we are going to focus in the subsequent slides. Coming to India solid waste statistics, so you can see here that annual waste is 62 million tons, plastic waste 5.6, biomedical 0.17 million tons, hazardous 7.9, e-waste 1.5 million tons. And if you talk about a per capita waste generation, you can see that nearly 200 grams to 600 grams per day we are generating. 43 million tons per annum is collected, 11.9 is treated, and 31 million in dump in landfill site, which is what I can say that it's one of the biggest challenge for most of the ULBs in terms of whatever the management is concerned, solid waste management is concerned, right? Even according to the Ministry of Housing and Urban Affairs, yes, there is any query?
No, sir. No, sir.
Okay, fine. Yeah. So if we talk about the Ministry of Housing and Urban Affairs annual report, Government of India, there are almost 700 functional compost plants in the country with an annual production capacity of 18.9 million metric ton. However, given the most plants are underutilized, currently only 0.2 million metric ton are produced from city compost. What is the reason behind this? I mean, it's a very maybe you can say that it's a very bad thing for all of us in terms of even if we are having a good composting plants in India, but still it is not working. What are the main reasons behind it? So the answer to this particular is unsegregated waste, right? So you go anywhere in India, even you go Pune city, you go Mumbai city, you go Hyderabad, you go Bangalore, anywhere you go, you will find that most of the places are not. I mean, in the most of the residential areas or places, you will not get a segregated waste. So according to the rules and regulations given by the Solid Waste Management Rules 2016, we have to segregate our waste in three different parts, that is wet waste, dry waste, and hazardous waste, right? But as of now, we are not doing that. In some cities, although they are doing, such as Indore is one of the good maybe example in terms of the management, and if they are not doing, then they have to pay some amount of fine, right? So this kind of maybe the policy should come, the stringent policies should come. The reason behind this unsegregated waste is, again, we can also talk about the stringent policies by the different cities or by the different ULBs, or maybe by the government, right? So that is what maybe we have to focus in the future, that how we can make those policies stringent. I'm not saying that we do not have policy. We have a policy, but those policies are not that much stringent in terms of paying the fines or something related to the tax and all those things, right? So these are the some of the silent features of SWM rules in 2016. So hotels and restaurants should segregate biodegradable waste and set up a system of collection to ensure that such food waste is utilized for composting or biomethanation. Now some of the hotels and restaurants are already doing it. I still know that one of the company which have initiated a work in one of the society which is having different hotels and all those restaurants. So they are collecting the waste directly from the hotel and restaurants as well as some of the societies, and they are converted into the biomethanation or biogas. Same biogas they are transporting to the same hotels so that they can they can cook the food and all those things. So that is how maybe the circular economy, that is what we have to focus in terms of the solid waste management, or in terms of whatever the organic waste management is concerned. Resident welfare association and gated communities with an area of more than 5,000 square kilometers should segregate waste and hand over recyclable material to either the authorized waste pickers or the authorized recycler. But in most of the cases, we are not observing such kind of situation. Even where I am staying right now in Pune, I have never observed in our society or in our nearby society in terms of whatever the waste management is concerned, right? Biodegradable waste should be processed, treated, and disposed of through composting or biomethanation with the premises as far as possible. So this is applicable for almost all the societies which are responsible in terms of producing more than 100 kg of organic waste, right? And if you go with more than 10 flats or 20 families, so you'll find that the easily 100 kg of the waste can be generated in a day, that can be easily composted. Biomethanation is little bit difficult in terms of the skills which is required, but otherwise composting can be easily done. Okay. Street vendors should keep suitable containers. High calorific waste shall be used for co-processing cement or thermal power plants. Now again there is another problem in terms of the thermal power plants. I mean we can say that I mean, not thermal power plants. We are talking about here the incineration. I mean, which are in general we do not get the high calorific waste, because whatever the problems we are having in terms of the segregation, so we are not getting high calorific value waste. So in general, we want nearly 1640 to 2420 kilocalorie weight of this particular waste, right? But at the same time, we are not getting, because of the amount of weight waste it is there due to the unsegregated pattern from the most of the municipal corporations, right? So that is what maybe we have to focus in terms of the waste management is concerned in a particular city or in a particular society. So if we talk about the current solid waste management system in India, so we can say that we are generating waste from the different sources. Then some places there is a primary collection, some places the residents are going to different areas where they are putting their waste into the dustbin. From the dustbin, the secondary collection will be done. The big trucks will carry the waste, and it will either send it to the landfill site, or some amount it will send it to the send it for the processing and recovery for the different types of waste. Now, if you talk about the scenario, you can see here on the right side that urban local bodies spend around rupees 500 to 1500 per ton on solid waste management, of which 60 to 70% of the amount is on collection alone. So you just imagine that if you are if you are spending this much amount of money only the collection part, then how you can treat it, right? So you need some good fund in terms of its management, in terms of its maybe you can say the treatment, a proper treatment, right? So that is again one of the issue. Another remaining 20 to 30% on transportation. Hardly any fund is spent on treatment and disposal of the waste. Crude dumping of the waste in most of the cities. So this is what maybe you can say, because of the unsegregated pattern of the waste, we are most of the waste we are directly disposing into the landfill sites, right? And ultimately from the landfill sites, CH4 or such kind of gases, CO2 gases will start emitting or start generating, or right. Again, at the same time, leachate production will be there, which will be having some amount of benzene, some amount of phenols, right? So that is again one of the issue which will percolate through the soil into the groundwater bodies. So the real problem exists into this. Maybe you can see here that the real problem is here that we are not we are not segregating it, and we are directly disposing same type of or unsegregated waste into the landfill site. Now you can see now who is going to segregate this. Even if rack picker will start segregating it, it will take complete life of that rack picker to do the proper segregation of all the different types of waste, that is what we are generating from the residential societies or from the different sources, right? So this is what maybe you can say the condition of the Indian cities or Indian areas or Indian urban areas we are observing, and that is what maybe we can say that one of the problem we are we have to, we have to address as early as possible. So there is one video from the Delhi landfill site. So we'll just go through that video. What are the problems in terms of the landfill sites are concerned.
Delhiites, here's the good news. Feel like trekking? You needn't travel anymore. Walk around Delhi and you'll come across huge mountains. If you can ignore the unbearable smell, toxic fumes and health hazards, you can even enjoy a great sunset from here. However, 2 people died after being buried under garbage at Gazipur. This, after 17 years of it being declared unsafe and 11 years after it lost its license. Deaths are not all. 40-acre Bhalswa landfill was ablaze for a week. Fire again broke out on October 20th this year and took a week to be doused off. Delhi's air quality oscillates between poor and very poor. These are Delhi's man-made trash mountains. From National Highway 4, take a left from Gazipur Sabzi Mandi and you can smell it. This still receives 2,000 tons of waste daily. It stands at 65 meters high, only 8 meters short of the Qutub Minar. Over 100 trucks and 30 loaders ferry waste on the dump site in 3 shifts daily. The official claim says that close to 1.3 million tons of waste has been thrown in the landfill since 1984. Now, let's head to North Delhi. Saturation point reached, but still receives about 2,700 tons of garbage each day. Last year, North Delhi Municipal Corporation said that this landfill will be turned into a green park on a budget of around 900 crores. Not too far off is Okhla. Commissioned in 1996, it still receives 1,700 tons of waste daily. To reduce the load on the dump site, a waste-to-energy plant was set up. But in 2014, a team of scientists found emissions from plant to be above permissible levels. National Green Tribunal asked Okhla WTE to pay 25 lakh as compensation. Before you turn away or roll up your car windows to avoid the stench, do you wonder how we managed to create these mountains? Well, Delhi produces over 10,000 tons of waste every day, more than the weight of the Eiffel Tower. That's 36,50,000 tons per year. Yes, continued dumping in one place is what resulted in these. For years now, Delhi has tried to find another landfill site. Unsurprisingly, no resident is willing to live next to one of these. With land limited, it is unlikely that they will succeed. Now then, hasn't anything been done about this menace? Since the first ever landfill, the government has tried different things but failed to succeed. Since clearly these haven't had much effect, what do? Well, you can change things. Segregate waste into biodegradable, dry waste and domestic hazardous wastes. This model has successfully been implemented in Alappuzha, Kerala, Panaji, Goa, Mysuru, Karnataka. 50% of all of Delhi's waste can be composted and 25% can be recycled if we begin to segregate. In the next 5 years, 36,50,000 tons of garbage will go into creating more mountains. So, do you think it's time to embark on a stinking trek? Or, before it gets too late, start taking action?
So I hope that you have understood the real benefit of the segregation, right? So these are also some of the images from the Guwahati landfill site where we have personally visited during the rainy season, and you can see the status of this landfill site where the rag pickers are also not able to, walk or can segregate the things properly, right? This is even a GMC, that is Guwahati Municipal Corporation truck, which generally comes for the dumping of the the waste into the landfill site. Again, that is one of the problem we are facing. This is a administrative building in IIT in this particular landfill site, near the landfill site, right? So this is, maybe we can say that one of the problem in terms of if we not segregate the proper waste into dry, into wet, as well as into hazardous, right? At the same time, if you go through the hierarchy, as of now we are following the first hierarchy, that is reduce, reuse, recycle, transformation, waste to landfill. So most amount of waste we are landfilling, and least amount of waste we are reducing, right? But we have to focus our, we have to shift our focus towards another hierarchy or new hierarchy, which not new, although not new, but maybe you can say the amount of the waste we have to, we have to reduce in terms of the landfill, and we have to increase the reduction pattern, or reduction particular process in terms of what are the waste we are generating, right? So what can be recycled? There are more than 200 items, different items such as light bulb, or maybe the keyboards, or maybe the metals can be recycled easily. But again, for that you need to do a proper segregation. Now let's talk about the organic waste. So organic waste is one of the biggest threat to the environment because it produces foul odor, it undergoes anaerobic decomposition and generates methane, also produces leachate that may contaminate soil and groundwater. Essential nutrients get wasted. So if you simply waste it, or if you simply dump it in open site, you will see such kind of maybe disadvantage, or maybe the problems in terms of the organic waste is concerned. Food waste alone causes 10% of greenhouse gas. At the same time, you can see the figure below that it is also responsible for CO2 emission and methane emission if you continuously dump it into the open landfill site. So organic waste is any material that is biodegradable and comes from either a plant or an animal. Biodegradable waste is organic material that can be broken into CO2, methane, or simple organic molecules, right? So there are various sources of organic waste. Again, we are not going to discuss that thing in detail because you are already knowing that municipal waste, industrial waste, and agriculture waste are generally considered. Most of amount of is nothing but the organic waste. Again, if we talk about the trends of urbanization, it is going to change with the trend. The amount of waste is going to increase. With the increase in the amount of waste, the treatment facility we need to increase, right? So again, it's very difficult in terms of the treatment facilities is concerned, because if you put much amount of just for waste management, then there will be some problem in terms of the financial condition of a country, right? So it's a personal, or it's an individual responsibility in terms of how organic waste can be managed within the society or within a particular residential area, right? So this is one of the figure that indicates the amount of the food production or food loss we generally observe in different regions around the world. Who is wasting the most food? The studies indicates that residentials are responsible for 44% of the food waste, restaurants 33%, from groceries it comes nearly 11%, institutional 10%, and industrial 2%. Now coming to the World Bank data on the on the different types of waste, so we can see that from the if you consider whole world or globe, you will see that 44% waste is nothing but the food and green waste, right? But we are spending a lot of money in India in terms of whatever the food waste is or the organic waste management is concerned in terms of the different cities, right? So even if you talk about the share of the states and union territories in urban MSW generated, so this is MSW generated overall from the different states. So you can see that Uttar Pradesh 10%, West Bengal 12, Maharashtra is at the top position where 17.1% we are generating MSW. Now, if you divide it into Class A, Class B cities, so you'll get different, kind of generation in terms of the metro cities are concerned, and Class A cities are there, and Class B cities are there. Now, if you see from all those different areas, maximum amount of the waste that can be reduced within the society or within the residential area or within the institutional area is nothing but the compostable part of the waste, that is nothing but the biodegradable waste. So you can see metros 50% is coming, other cities are also 51%, East India 50%. So almost more than 50% is nothing but the organic waste, and we can easily decompose this organic waste by adopting some effective method in terms of the organic matter is concerned, right? So what are the options to treat organic waste? So we have anaerobic digestion, which can be easily I mean, by which we can convert organic waste into the biogas. We can also feed this organic waste to the different animals such as pig farm or some different farms where the animals are required some food for their growth. So that can be done in some of the cities. It is already there. Biochar production, the waste such as agriculture residues can be easily used for the biochar production, which can be done by pyrolysis. Biofuel production nowadays, algal based fuel or ethanol based fuel is also coming in the market. I mean, will be coming in the near future. So biofuel can be also done. Briquettes production can be done. Composting is one of the activity can be done, or one of the method that can be used. Vermicomposting, it's just advanced to the composting where we are using earthworms. Different types of earthworms are available, such as perionyx, hydrillus, eugene. So a lot of different types of species are there, which we can use in terms of the composting is concerned. And at the end, we can also go for landfill disposal. But obviously, landfill disposal is not a good option in terms of the organic waste management is concerned. So the best option is nothing but the composting, because all the other options maybe require some kind of financial or some kind of economical investment in terms of society is concerned, or in terms of residential areas are concerned, right? So composting can be done very easily in terms of the labor, in terms of the skills that are required to manage the composting or to manage the different factors in the composting, right? Now, according to the statistical data again given by the World Bank, so you will see that most amount of the waste organic waste we are directly putting into the open dump site, whereas least amount of waste we are composting. What are the reasons? Again, we can say that we are not aware about that the composting can be done easily, or some of the factors are there which we have to manage. No doubt it will require some kind of some amount of patience, or at the same time some amount of understanding to understand that what are the factors are responsible for composting, right? So why composting? It reduces landfill, allowing biodegradable materials to break down. Organic broken down above ground turn into fertilizer. That fertilizer can be used for gardening purposes within your society, within your residential area, or maybe you can sell that fertilizer, organic fertilizer, to the farms or to the nursery. It save money on landfill cost. Obviously, ULB's money will be saved if you will start managing your waste within your society, right? And it saves planet by utilizing its natural resources. Now, what is composting? So you can say that composting, in which we generally put two different things, that is brown matter and green matter. We mix it in a proper proportion. Maybe you have heard about C by N ratio, that is carbon to nitrogen ratio, which is one of the prime factor in terms of the composting is concerned, right? So there are a lot of such raw matter is there, maybe not raw matter, we generally say it as a maybe waste matter. So there are a lot of such raw matter or waste matter is there, which is organic matter, fishes, bedding, feed, different types of maybe you can say the dry material is also required, such as grass clippings or sawdust. So different green matter plus brown matter we have to add, we have to mix it in a proper way, and then we have to follow the proper protocol in terms of what your composting is concerned. So according to the Hawk, defines composting as the biological decomposition and stabilization of organic substrate under the condition that allows development of thermophilic temperature. Now here is one important thing that we have to understand in terms of the composting is concerned, that nearly thermophilic temperature requirement is utmost importance in terms of the composting is concerned, because if the thermophilic temperatures, that is more than 45 degrees Celsius, is not we don't get this much amount of temperature in the composting process, in that case the pathogens will not get destroyed. Whatever the pathogens, whatever the harmful bacteria are there in your waste will not get destroyed, and that will reduce the quality of the compost. So that is one of, you can say, the prime factor for the composting process. Okay, so although the composting is not new, so you go through the literatures, you will find there are lot of studies in terms of how the earlier human beings were converting their waste into the compost. So you can say that nearly 2320 BC we have some history about this composting. Then 50 BC also we can say that the composting continued. 12th century, 1940s we invented Bangalore and indoor composting method, that is Indian method. in 1970s or after 1970s, lot of new methods have came into existence, such as windrow method or pile method or in vessel method, right? Nowadays a mechanized version also are there, automated versions are also there in terms of the composters are concerned, right? So coming to the basic principles, so brown matter plus green matter in presence of the oxygen. So always remember that composting is a aerobic process, it's not an anaerobic process. If anyone says anaerobic process, that is not a composting. Okay, so composting will be always aerobic process. So you need some amount of oxygen, some amount of air to complete this composting process, and at the end whatever you will get, that will be considered as a humus nature substance, that is nothing but the compost. Now this is a basic chemistry with maybe you can say the chemical reactions that occurs in this maybe in this particular composting process. So compost mixture, or maybe you can say the raw matter is generally made up of three different things, maybe the protein, cellulose and lignin. Now in the presence of oxygen, they convert it into different molecules, right? So that is CO2, H2O, sugars, cellulose converted into CO2, H2O, sugars, and lignin converted into slightly modified lignin. Now you see, this is a very important thing to understand, that agriculture waste cannot be easily composted because of high amount of lignin content, right? So if you talk about the wood, it won't be easily converted into compost because it's having high amount of lignin, under which we will having some amount of cellulose, under that we will be having some amount of hemicellulose. So it's very difficult in terms of the lignin degradation is concerned. But yes, the amount of protein and cellulose can be easily converted into the other kind of molecules. And after this complete biochemical reaction, you will get a stable organic matter which is free from pathogens, which is having humus like nature, which smells like a soil when soil is wet, right? And that having a good amount of microbes which will actually help you in terms of for the degradation of that particular organic matter which is present in that in that compost mixture. So this is what maybe you can say the biochemical reaction is involved in this particular composting process. So these are the different materials. So carbon materials which provides the carbon to your composting process, and nitrogen material which provides nitrogen to your composting process. So we'll go through the factors one by one. What are the factors are responsible for having the proper composting process? But these are some of the materials which can be composted in terms of what are the composting is you have to perform in your society or in your residential area. So coming to factors affecting process, so organisms, that is the microorganisms, is one of the factor. So that is also one of the important thing maybe you can say during the composting process. Use of cultures, different cultures. Suppose your waste is not having a proper amount of microorganism in that, you have to get extra cultures so that inoculums will be added, and it will help you for the faster decomposition of your waste. Moisture content is another factor that may affect your process: temperature, Seaborn ratio, aeration, pH and time, particle size, and finally curing. So these are the major factors that affects your composting process, right? So let's talk about the microorganism. There are various microorganisms, and these microorganisms are mesophilic microorganisms, thermophilic microorganism, again secondary mesophilic microorganism, and they rely on each other in terms of the in terms of the waste degradation, or in terms of the food, or maybe you can say in terms of the growth of those microorganisms, which are very essential to degrade the organic matter present in your waste. So initially when you put organic residues mixed with different matter, maybe brown matter and green matter, so these primary consumers are totally dependent on the organic residues for their growth, for their reproduction. At the same time, the secondary consumers are reliant on the primary consumer for their food and for their growth. Once these secondary consumers will die, the tertiary consumers will be taking maybe you can say the main role in terms of your the waste manage in your organic waste degradation, whatever other thing, whatever waste you have already fed into the reactor or into the piles, right? So these tertiary consumers also eat secondary consumers, and these tertiary consumers are nothing but the centipedes, predatory mites, rough beetles, pseudo scorpions. So these are some of the bacteria which are generally found at the end stage of your composting process, right? Now, if suppose your waste is not having good amount of microorganisms, in that case, you have to use a cultures. So cultures are nothing but the inoculums. In market, you will get some kind of cultures, packed cultures. You have to put it into a proper amount, which already will be given on that particular packet or that particular product. Or if suppose you don't want to buy anything from the market, then get a cow dung, because we have understood that cow dung is having good amount of microorganism and can help us in terms of increasing the amount of microorganisms into the composting mixture. So we add cow dung sometimes in a proper proportion. By understanding the different error and analysis method, we get to know that how much amount of composting, how much amount of cow dung we have to add for a composting process. The another important factor is the moisture content. So the optimum moisture content given by most of the studies is 50 to 60%. Now, what you have to do, that you have to hold the compost in your hand, and you have to check whether the water is coming or not. If water is coming, that means your quality of compost is not good. But if water is not coming, it is not forming any lump, in that case, yes, you can say that our quality of compost is very good in terms of whatever the compost you are producing, right? So 50 to 60% is the optimum moisture content. I'll come up with some case studies where you will get some more understanding in terms of how the moisture content can be measured. Temperature is one of the important thing, because as we have already discussed, that 45 degree Celsius of temperature, if it is not getting, in that case you will observe that the composting process is not going good, or maybe the pathogens will not get killed properly. So in that case, your compost quality will be not good, right? So you have to focus always on the temperature. So basically there are four phases of the temperature. The first is a mesophilic phase. So in the first few days, you will find that your compost mixture will attain a temperature of 0 to 25 or up to 35 degrees Celsius. Once the mesophilic bacteria will diminish, then the thermophilic bacteria will take their role. The thermophilic bacteria generally lies between 45 degree to 60 degrees Celsius. If your mixture, if your compost process is having 3 to 4 days of 45 degrees Celsius to 60 degrees Celsius, that means your composting process is going good, right? So you can measure the temperature between this composting process by putting thermometer. So there are different thermometers available in the market. You have to just put that thermometer into the into that composting mixture, and you will get the readings regarding this temperature pattern. Okay. At the same time, C/N ratio is one of the important thing. Carbon to nitrogen ratio is very important thing. If nitrogen is very less, in that case, in that case, ammonia gas will be released more. If carbon is more, in that case, your decomposition will become very slow. So you have to maintain the C/N ratio, that is carbon to nitrogen ratio, in the 25:1. So this is one of the optimum C/N ratio given by most of the studies. You go through any literature, any studies, you will find that 25:1 is one of the good C/N ratio for most of the composting process. Coming to next is the aeration. Aeration is most important, as I told that this is an aerobic process. So if you won't provide a proper air in the composting process, so your composting quality will be not good, or maybe there will be problem in terms of the leachate production. I mean, if it becomes anaerobic, if there will be not sufficient air for the growth of the microbial action, so the degradation will not occur properly. At the same time, it will start producing some amount of leachate. So I think I have already discussed about leachate. It is having BOD more than 40,000 mg per liter or 50,000 mg per liter. So that is what may be again very difficult in terms of the organic waste management is concerned. So obviously you have to provide aeration. Sometimes if you have to do the mixing in some kind of composting method, or in some kind of method, you can put some kind type of machines, that is blowers, that will help you in terms of in terms of managing the air within that particular composting mixture. So I'll show you some videos on that particular aerated static pile. Okay, coming to pH. So pH is again another important factor in terms of the growth of the microorganisms are concerned. So in general, 5.5 to 9 is I mean, most of the studies have indicated that the composting was done in between 5.5 to 9, but whereas in general 6.5 to 8 is one of the best pH for the microbial action as well as for the composting process to be carried out, right? Coming to time you have to give depending upon the process a sufficient time you have to give. For example, if you talk about the windrow you have to give nearly 120 days to 150 days. For pile you have to give 30 to 45 days. For in-vessel composting, I'll show you one in-vessel composting. For that, you have to give nearly 20 days. So minimum 20 days. So this is how maybe the dependent on the time you are having or dependent upon the method you are adopting. It is based on that you have to give a proper time. Particle size, it is better if you can, put a particle size between, 2 inches of diameter. So it will help you in terms of for the proper degradation and the faster degradation. If your size will be more, then it will become difficult for the microorganism. See, you have to understand that the microorganism don't have teeth, right? So if it is the case, then how they will degrade, how they will eat. So that is why you have to provide with a small amount of or maybe small size of the particle. So 1/8 to 2 inches average diameter is okay for this particular composting process. Coming to curing, so once the composting process is is over, maybe 20 days are over for the in-vessel process. In the after that you have to keep it for maybe 3 weeks or maybe 1 or 2 weeks is also sufficient for the in-vessel composting, whereas for the windrow composting you have to keep it as it is for 3 to 4 weeks, right? So that is nothing but the curing stage, where all the remaining microorganisms which we are working for the decomposition will automatically get reduced, so that they won't affect your soil, they won't affect your plant in the future, right? So that is what maybe you have to focus in terms of the factors are concerned for the composting process. So these are the guidelines for the composting given by different organization in terms of how the compost can be produced, what should be the quality of the compost. So you can see carbon to nitrogen 25:1, 30:1, moisture content 50 to 60%, oxygen concentration much greater than 5%, particle size it varies depending upon the waste, pH 6.5 to 8, and temperature 130 to 140, that is in degree Fahrenheit. So you can say that comes up to 45 to 60 degrees Celsius will also helpful in terms of the thermophilic temperatures which are the requirement of the composting process. So there are various materials and many studies have already indicated their C/N ratio, their moisture content. Now if suppose you have some amount of waste coming from your society or from your colleges or from your institution, so you can easily go ahead, you can go through different materials, find out the C/N ratio and maintain the C/N ratio during the start of the composting mixture. So this is how maybe you can get good information from the different studies in terms of their values are concerned. Okay. Now coming to types of composting, we can see here that there are basically different types of composting. Some are open systems, some are contained systems. Now in open systems, which are open to sky or maybe can be done in open areas. So that is nothing but the windrow composting, aerated static piles. Whereas contained system, which can be done in a proper bin or in a proper contained area. So you can see that vertical type flow is there. Horizontal flow, that means the horizontal drum or horizontal cylinder is also there in terms of the contained system is concerned, right? And tunnels are also there, batch tunnels are also there, kind of a rotary drum, all those things will be considered as a batch tunnels. So coming to windrow composting, it's one of the conventional method most of the countries are following. In whenever there more amount of waste is generated, organic waste is generated, in that case we use windrow composting. Now it's one of I can say that this composting is a very older method for the composting, but it takes a longer duration in terms of managing that particular waste, because you have to mix it properly, you have to turn it properly, otherwise your compost will not be like the good quality compost which is having a good quality of nitrogen, phosphorus and potassium, right? So many things are there in terms of the windrow composting, and you have to do the turning regularly. I mean, for any case, for any type of composting method, you have to do the regular turning. But for such windrows, it's very difficult by manual one, right? So there are a lot of such equipments which can be used for the turning. I'll show you one or two videos on that equipment, how it can be turned, right? So these are some of the design consideration. The cross-sectional dimensions vary with feedstock and turning equipment, but most municipal service windrows are 1.5 to 2 meters high and 3 to 6 meters wide, right? Windrows composed of MSW are usually required to be located on an impermeable surface. Such a base should be paved with impervious floor of 200 mm thick cement concrete over a 250 mm thick compacted earth and 150 mm thick PCC base. So these are the prerequisites for the for starting our windrow process, right? 2% slope and line drain to be provided for collecting leachate. So obviously when you turn, when the biodegradation will occur, obviously some amount of water will come from that process, and for that you have to provide a proper collection of leachate system, right? So that is one of the important design consideration. Now I'll show you how to turn these particular windrows. Again, it's a little bit costly in terms of the equipments are concerned, but the equipments are really help you in terms of managing the waste with ease. At the same time, labor will require less, and your windrow will finish instead of 150 days, it will finish in 120 days. So this is how maybe you can say that the turners are helpful, right? So this is one. Another video. This is how maybe you can say that the turning can be done, and it will help you to save the time as well as to help to labors in terms of the mixing is concerned, right? There is another method which is aerated static pile composting. So as I said that window take 120 days, but whereas this pile composting takes some less amount of days, maybe you can say between 30 to 45 days. This particular process can be I mean, we can finish the complete process of the composting of by this aerated pile. So compost piles, now if you consider the size of the piles, it is comparatively smaller than the windrow. So you can see that composting piles with 6 meter length, 2 meter of width and 1.5 meter height can be formed. Free airspace and bulk density of raw materials are determining factor for selection of method. You have to provide a blower which requires 0.5 horsepower electric motor and air capacity of 1000 meter cube per hour. 50 mm PVC pipe you have to distribute within I mean below that particular that pile. I mean whatever the compost mixture that you are going to put. So you have to install some PVC pipes having some small holes so that air can be air can be given properly to that piles, right? So each of the holes open on the pipe has a diameter of 8 mm at 20 centimeter intervals. Ventilation pipes laid on the bale of straw coated by greenhouse covering material fit with 50% openings. So this is maybe you can see the design considerations are there in terms of the aerated static pile, and it takes less time compared to the windrow method, right? So this is one of the video which for the positive aeration mechanism. You have to lay down such pipes. basically the cover are placed in order to do the faster decomposition so that the fungus will create, and with the fungus more amount of degradation will be possible in terms of the aerated static piles are concerned, right? So this is one of the type, although it's not used widely in terms of the decentralized method, whereas windrows are also not used widely in terms of the decentralized method, right? Most of the times those are considered as a centralized method. But in vessel composting is one of the method which we can use as a decentralized method. For most of the societies, residential areas can use this type of composter, or maybe the rotary drum composter, or different types of such composter that will help you in terms of managing your waste in your society as well as in your residential areas, right? So this is one of the figure, one of the image of the rotary drum composter, on which personally I have worked during my research at IIT Guwahati. And this rotary drum composter is made up of mild steel, which is having a rotating arm to rotate it. So we have to rotate the this particular drum in a day once, because the mixing is very important in terms of the composting, and it can handle nearly 100 to 150 kg of waste. So you required only 20 days for the for convert the waste into the compost, whereas pile takes 40 to 45 days, whereas the windrow take 120 days. So maybe this is how you can say that decentralized method is very beneficial in terms of how it can help us in managing the different waste, different organic waste coming from your societies as well as your residential areas, right? So there are some
Municipal
videos.
waste is the major problem in recent years. Like waste converters, we manufacture techniques and services close it. Forget it. Load organic waste through inlet along with carbonaceous material and composting culture. You can add vegetables waste, fruits and fruit skins, cooked or uncooked, meat, eggshells, bread or bakery items, street sweeping leaves and tree branches, flowers, temple waste. Do not add coconut shells, pharmaceuticals, cosmetics, glass, metal, newspaper, magazines and plastic bags, bottles, dog or cat droppings, sanitary pads, nappies. Mixing, curing is automatically done by the machine. Quick Composter is a fully automatic biomechanical composter and a continuous organic waste converter. It is our most popular product with a proven and sustainable microorganism-based technology. Organic waste composter converts the organic waste added to the machine into nitrogen-rich compost by reducing its volume by almost 80% of the original. Organic waste includes kitchen waste or anything that comes from plants or animals and is biodegradable.
So you can say that rotary drum composter are there. Some are automated, some are the manual one. Automated are costly, but and generally not preferred for the small societies or residential areas. Whereas this kind of maybe you can say the small drums which I have showed earlier can be used for different societies and residential areas, right? So maybe this is one of the beneficial in terms of managing the organic waste, right? So you can see inside the rotary drum composter you will have such kind of metal angles which will help you to turn the to mix the waste properly. At the same time, if any size by mistake you have fade which is higher than whatever required, so it will also cut that particular waste in terms of the optimum size that is required for our composting process. So this is maybe helpful in terms of managing our waste within the 20 days, right? So there are a lot of maybe you can say the problem and remedy for the different types of problems, such as bad odor is there. Then that means your waste is too wet, needs more air. So you have to mix it with a proper dry material, which will help you to manage the wet conditions of your compost. If process is too slow, that means your temperature pattern is not proper in terms of the weather is too cold or the particle is not in a proper size. So you have to manage your composting process in terms of managing the, you have to do that composting in a proper contained system. If the center is dry, not enough water, add some amount of water. So if your process is very dry, if you feel that your process is going very dry, in that case you add some amount of water. So it depends upon how you have to, how you can manage your composting process within your society or within your institute, right? Again, there are some, maybe you can say, the differentiation which I have come up with, which indicates that which method is beneficial in terms of managing the waste. So almost all different types of waste can be managed in vessel. Land requirement is very low, so that is what our concept is about, the decentralized composting method. Composting period is very short compared to any other method. Product quality is good, whereas windrow and ASP, as the waste is in a very bulk quantity, so in that case we can say that the quality will be medium to good, right? Compared to the economical impact of various in composting system, so you can here see that in vessel is little bit costly in terms of, because you have to procure some metal and all those things. So in that case it is very costly, but in terms of labor, so long term duration, if you will see, it will cost less. So you have to think about the long term duration, not in a shorter duration, right? Even environmental impact of various composting method is medium in case of vessel, because in windrow you will be putting lot of waste, and the amount of waste during the degradation process, it will release some amount of CO2, CH4, so it is have some impact on the environment, right? So these are some of the very important in terms of the selecting which type of method you have to follow for your particular area, for your particular society. So as of now, focusing on centralized waste management. You go any city, most of the cities are having a centralized waste management, where most amount of waste we are generating, we are putting, we are most of the ULBs are working on the waste management, whereas nowadays concept is coming about the decentralized waste management. So you have to segregate the waste properly. Organic waste you can convert it into compost or biogas if you have a proper amount of fund in your society or residential area, right? Otherwise, you can convert it into compost. Dry waste can be further sent to the recyclers, whereas sanitary or whatever the hazardous waste is there, you have to send it to the proper person that will collect this particular waste. So if you talk about the centralized versus decentralized, so you will see that transportation cost will get reduced, operation and maintenance cost will get reduced, labor skill low level is required, technology simple, whereas in centralized system big machineries are required, facilities wise, again you have to require very small facilities. In terms of decentralized system, quality compost will be high because you are managing small waste in a proper way, so obviously the quality will be more good in terms of if you compare it with the centralized system, right? And final product, you can sell it to the different nursery or farmers, or maybe because not much amount of waste will be generated, right? Not much amount of compost will be produced, so you can sell it to the farmer, or otherwise you can use it for the gardening purpose, right, in your society itself. So this is how centralized systems nowadays are very helpful or very beneficial in terms of how the waste is managing. Okay, so there are many such case studies in Mumbai. This is one of the institute from that microbiology department at Satahe College has been managing its biodegradable waste for the last 7 years. So they are doing actually by vermicomposting, not by composting. So the worms were bought from a local nursery with an initial investment of 300, whereas they have constructed this vermicomposting pit at the cost of rupees 30,000. But otherwise, the method is very easy to manage the vermicomposting as well. Okay. Similarly, another study from the Ville Parle area. So Mr. Satish Kolvankar, an active resident in Ville Parle, has not sent out any kitchen waste to municipal corporation for the last 20 years. And this is how maybe you can say that your waste can be easily managed within your society, and the ULBs will also have less burden in terms of managing all the other waste, right? So that is what maybe you have to focus in terms of whatever the organic waste management is concerned, right? There are a lot of case studies, but I will focus on only one case study, which is on a Hydrilla verticillata. So lot of different type of waste can be converted easily. Sometimes you have to find the leachate, you have to calculate the leachate, amount of leachate, what is the amount of BOD and COD. And this study what I have performed in during my MTech, and which is on a pile composting method. It's not a aerated pile, it's a static pile. So we do not have aerated by putting some blower and anything, right? So you can see the amount of water is coming from this particular pile method. And we have also done some leachate analysis in which we have observed the amount of leachate is more during the thermophilic conditions, that is between 45 degrees Celsius to 60 degrees Celsius, right? At the same time, initially the BOD was very high, more than 20,000, 25,000. COD was more than 40,000. But with time, due to the degradation of organic matter, the BOD got reduced, right? So this is how maybe you can also perform in your institutes, that different types of studies in terms of the organic waste matter are concerned. And this, you can see the pictorial view. This is a setup that we have done for the leachate collection, and you can see the leachate for the different types of mixtures. Now I'll show you another method that is rotary drum composting. I'll focus on this method because it's one of the best method in terms of the decentralized process. So what we have done is a composting of aquatic weeds. As you know that lot of aquatic weeds are growing in the water bodies because of illegal disposal of the liquid waste into the water bodies, and ultimately it is harming most of the animals, most of the aquatic animals which are in that particular water body. So these kind of conditions are everywhere around the world, not only in India. Eutrophication conditions are everywhere around the world, and this is occurring because of whatever the waste we are disposing into the water bodies. And these are some of the weeds which we can see on a daily basis in different aquatic life or aquatic bodies, and can be easily converted into the compost, right? That is what I have done in my PhD. Now talking about this one of the weed, Hydrilla verticillata. It's a submerged weed that is found in almost all the different continents. Whether you talk about Asia, Africa, America, everywhere this Hydrilla verticillata is found, and it's a very dominant in terms of the water, the plants we are growing that are growing in the aquatic life. It's very dominant, and it grows as a submerged this aquatic weed. So this is a photo of this particular aquatic weed, Hydrilla verticillata. You can see these are some of the images from India, which shows that the lakes are also completely filled with this kind of aquatic weed. This is one of the image from the Punjab, right? This is in Florida. So a lot of such issues are there around the world, and the impacts, you can see that if the aquatic weeds are there, then they will reduce the oxygen, they will increase, maybe you can say, the death of animals, aquatic animals. They will alter the chemistry, they will chemistry of water, they will interfere with the navigation and irrigation channels. So that is what maybe one of the problem that we can see with this kind of method, or this kind of weeds, aquatic weeds. So what we have done, we have collected the aquatic weed. We have used cow dung as an inoculum, because I mean, we have done some amount of some analysis on the amount of inoculums, that is fungi, streptococci, and all those things, and we have observed that very less amount of pathogens and inoculums were available. So we have thought of going with a cow dung as an inoculum, and we have used a sawdust, because as you know that the Hydrilla verticillata is having more amount of moisture content as it is coming from the water body. So we have composted it with a sawdust, which is a dry material, right? So we have operated in a batch mode. We have fed the waste in a proper mixture in a different proportion, and we have done some trial and error method in terms of understanding that what is the optimum ratio is required for managing this kind of waste. So we have done various types of parameters: pH, EC, TKN, ammonia, total phosphorus, available phosphorus, volatile solids, TOC, that is total organic carbon, ash, moisture content. We have also done initial characterization, because without initial characterization, it's not recommended to go for a composting. So with the initial characterization, you can at least understand that what amount of C-band ratio is required, and what amount of proper amount of dry materials are required, or amount of wet waste is required. So based on that, we have observed that moisture content was very high, and that is why we have added the sawdust. So these are different ratios we have performed, that is 541, 631, and 721, and we got very good results with the 811, that is 8 8 parts of substrate, that is Hydrilla verticillata, 1 part of cow dung, and 1 part of sawdust. It gave very good result in terms of in terms of whatever the composting of Hadila verticillata is concerned. And this is how we have done the composting. I mean, we have collected the waste, we have collected the cow dung, we have collected the sawdust, we have mixed everything homogeneously, thoroughly on the ground, and ultimately we have fed into the rotary drum composter. This process went for 20 days, 0 to 20 days. Every day we were turning the compost this reactor, and every day we were measuring the temperature to understand whether our process is attaining the proper temperature which is required according to the given literatures or not, right? So we have got very good results in terms of the temperature as well. So these are some of the mixed proportion ratios, and these are some of the results and discussions. So here you can see that we have attained a good amount of, I mean, good temperature, that is 53.7 degrees Celsius, right? And as a requirement that at least for 3 days we should want more than 45 degrees Celsius. So yes, we got more than 45 degrees Celsius with a 8:1:1 ratio. Even we have observed that moisture content got reduced properly, that is 60% reduction maximum occurred with the 8:1:1 having the maximum reduction. Maximum reduction in the volatile solids, that is nothing but the organic matter which were present in the our waste, got reduced drastically from the 80% to nearly 65%, right? Similarly, you can see the BOD and COD we got reduced. This is a soluble BOD and soluble COD that we have calculated by doing proper experimentation. So we got very good results in terms of reduction of the organic matter, which is, maybe you can say, the pollutants, BOD and COD, right? Even we have observed the total gel nitrogen and total phosphorus, whatever the essential nutrients are required, which are very important in terms of organic waste is concerned, right? So we got very good results in terms of nutrients. So increment is there, nearly 60% increment from the existing conditions. Existing, I mean, that is the 0-day condition. So we got very good result in terms of NPK, right? These are the coliforms. These are the bacteria pathogens. That is what we always talk about, the pathogens that got reduced certainly in a trial 4, that is 8:1:1 ratio. And that indicates that our process got in a very good manner, and we got very good results in terms of the quality of that compost, right? So this is some in some in some phase of this composting method, we have also observed some amount of water in trial 5, but again we got a very good results with trial 4 and not trial 5. So this was after that we got, I mean, this is just for understanding. Okay, if you are not adding the things properly, then it may affect your composting process, right? And okay, so this is how maybe you can say we have done the study. And this is another study we have done with a biochar. We have added the biochar, which provides a good amount of carbon in the composting process, right? So again, here we got very good result in terms of the temperature, in terms of the moisture content, in terms of volatile solids, VS losses. So all those studies are published. Maybe you can also go through my Google Scholar, where you will find this biochar study. It is already published, and you will get more insights in terms of how the composting can be done by using the biochar. So you see that it's a free flowing compost we have achieved by using the biochar. Similarly, there are a lot of studies in terms of the composting of vegetable waste is concerned, and we have observed that 5:4:1 is the one of the good study, one of the good ratio, that is 50 kg of this vegetable waste, 40 kg of cow dung, and 10 kg of sawdust plus 10 kg of dry leaves are very helpful in terms of managing the vegetable waste, because vegetable waste have a lot of organic acids. So you can manage it by putting more amount of dry leaves or bulking agents, or maybe you can also add biochar. So maybe this is how you have to manage the things. So I have already discussed the factors. You have to monitor the factors always, so that you can manage your composting process easily, right? So there are a lot of studies in terms of the vegetable composting. Now coming to the opportunities for soil, we have a lot of opportunities. Soil fertility and quality can be improved. The dependence on the heavy metal or dependent on the chemical fertilizers will be reduced, and definitely it will improve your soil quality, soil physical characteristics, or soil biological characteristics or soil nutrient level characteristics, right? And nowadays, lot of businesses are coming. There are a lot of advantages with this kind of composting business. So landfill will get benefit in terms of managing our waste within our site. Startup cost is very less in compare with the other such industries or businesses. Tax intensive incentives will be there. It will create jobs. Technology, new innovation will come with the new businesses, and you can definitely improve your economy in terms of money, right? So this is one firm as far as I know about the recent firm which have started with the composting, and these graduates are from the IIT itself, and they are doing very well in terms of whatever the composting is concerned for the residential areas and residential societies, right? So there are such various videos are also there how to do the composting within less space within your residential area within your society, and can be done very easily. Okay, and this is my contact information. If anyone wish to know more details on whatever we are doing and what can be done for your institute or for your society and how to do the experiments, so you are welcome. I'll definitely share more details in terms of if you need some assistance from myself. Okay, so thank you so much. And if you have any queries, any questions, you may go further and ask. Yes, anyone have any questions, any queries?
Thank you, Dr. Jain. The participants can ask questions either in the chat or you can directly ask.
Hello.
Yes, yes. Ask.
Sir, I am Dharmesh Jariwala from PPNet.
Yes.
I am audible, sir?
Yes, but your voice is not clear, sir.
Sir, it is audible now?
Yes, yes, it is audible.
Sir, it is a wonderful presentation. But I would like to know which are the various methods, that is the pyrolysis, incineration, and the plasma calcination. Okay, so which are the best methods for the energy production from the organic waste, according to your view?
Okay, okay. See, basically, if organic waste, when we talk about the organic waste, it is very difficult in terms of the thermal treatment, right? I mean, if because organic waste is yeah. Am I audible?
Yes, yes,
Yes,
yes.
yes. So, talking about your question that it is not it is not better to go for this pyrolysis or incineration whenever we talk about the organic waste, which is having some amount of water. And wherever you go, you'll find that organic waste is having more amount of water compared to the dry waste. So, if you talk about organic waste, either you can go for biogas or you can go for composting, right? So this is maybe I can say that biogas is one of the suitable method in terms of your waste is having more amount of moisture content, maybe more than 80% and 90%. As at that time also you can go for a biogas. So definitely from biogas you can generate the electricity. But thermal incineration, that is what you have focused, pyrolysis or maybe the incineration. Incineration is better for dry waste, and we have a lot of incineration units or incineration plant in India, but some of them are not working. Again, whatever we have discussed, because we have unsegregated waste. So dry waste is generally mixed with the wet waste. So it's very difficult to go for again waste to energy in India in terms of incineration is concerned, right? But pyrolysis, yes, you can go for organic waste such as for agriculture residues. You can go for pyrolysis, from which you can produce a biochar, which are really very beneficial in terms of the soil conditioner. So this is how you can do the things in terms of the organic waste are concerned.
Okay, thank you, sir.
Yes. Okay.
There is another question in chat section by Dr. Suchitra Rajput Chauhan. That is there any initiative from government for segregating the waste at first step at home or industries?
I'm not getting the question clearly, sir.
Yes, she has asked, is there any initiative from government for segregating waste at first step, that is at home and industry? Like in USA, one has to keep different type of waste in different type of bags before
Yes,
sending.
yes. So according to if you go through the solid waste management rule 2016, that is what we have discussed initially, that we have a set of rules in terms of how to segregate the waste. So we should have a three buckets. One is for the green wet waste, one is for the dry waste, and one is should for the sanitary waste or maybe hazardous waste. So by adopting these different dustbin, we have to segregate at the source itself. I mean, the rule is there, but again, the same thing, I will come to the same point that most of the, most of the community, most of the people are not aware about that rule. And even if they are aware about rule, but simply I'll tell that most of the communities are lazy in terms of segregating the waste, right? So that is what maybe we, as an individual, we have to focus, because government can't do anything in terms of the source segregation. You have to, I mean, as an individual, have to perform this activity to segregate the waste. But yes, we have a rule.
Uh, Sir, can I ask a question?
Yes, yes,
Yeah.
Mr. Yogesh, yes.
Yes. Uh, Most of the urban population in living in the multi-story and such as smaller space. Okay, so for them, if they want to do the at a household level some composting, then which is a easy and odor-free and nuisance-free solution that they do not have to buy any culture from outside, or is there require any bulking agent, or they can do easily without anything, any good compost at a household level only, not at
Yes.
society level?
Yes, yes. Very good question, Yogesh sir. See, as per your question, I still remember that last year, I mean during 2019, most of the institute and all those thing activities were closed. So during that, I have I have created one kind of composter which can be used at a household level, just for understanding that whether the study can be done or not. So we have created one household composter, and it's very easy to do the composting at home. Whatever the waste you generate on a daily basis, you have to put it into that particular composter, and you have to turn it by by proper mixing it with a proper equipment, or with a proper maybe you can say the wood stick, right? So you have to mix it. The only thing that you have to monitor is the amount of carbon material and the nitrogen material. So if you talk about on a daily basis, we have a coconut, right? So you can put some amount of jute into that. If not getting you are not getting bulking agent from anywhere, then in that case you maybe put some amount of soil, because soil will have a good amount of microbes, right? So that microbes will help you in terms of getting good quality of compost. So it can be done easily within a small container. Even you can also innovate your own composter, and you can start your composting. That's not a big thing. Only the thing you have to focus is the temperature attainment. So if your temperature attainment is not good, in that case, maybe at the end you will find that the compost material will be not having of a good quality. But otherwise, yes, it can be performed easily, and that is what I have showed in a small video which is at the end of our slide. I have already shared with Professor Singh. Maybe he'll share that video link with every one of you. Maybe if you want more details in that, I'll definitely help you in terms of sending that link to your email ID as well. Okay, but yes, it can be done without bulking agents acquiring from outside. So you can use the soil and you put your wet waste into that composter on a daily basis.
Okay, thank you, sir. And is there any government is recommending that for agricultural uses, you have to quality parameters are such, or they mention such quality parameters and you have to fulfill it? Is that anything for
Yes,
agriculture?
Yogesh sir. A government have already given the fertilizers control order FCO 2013. You just go through these limits given by that FCO that indicates that your compost should not have bulk density more than 1,000 gram per 1,000 gram per cubic meter cube, and at the same time your nitrogen should not it should not less than 0.8%. Your phosphorus should not less than 0.4%, right? At the same time, carbon should not less than 0.4%. So all those details regarding the parameters, recommended parameters given by Government of India is there in FCO 2013, that is Fertilizer Control Order.
Okay, sir. Thank you very much.
Yes.
Okay, one question by Dr. Uma. Any superior method for converting biofuels to energy? He has asked.
Biofuels into?
Energy it is written.
I do not have that much detailed study on that biofuel part, but maybe I'll go through it, and definitely I would like to help in terms of whether there is any such kind of method available or not.
Okay. Any other participant if they want to ask the question?
Excuse me, sir. Shall I ask you a question, sir?
Yes.
Sir, is there any instrumental model available for the production of biochar?
Yes, sir. What you are saying, sir?
Actually, what I'm asking is there any instrumental model or instrumental design commercially available for the production of biochar?
Instrumental design. Okay. No, as such, you can go for a pyrolysis nowadays. I mean, most of even where I was doing my research at IIT Guwahati. So some of the faculties have innovated their own pyrolysis unit for their own purpose. So there are a lot of such pyrolysis instruments that you can use for production of the biochar, sir.
Okay, sir. The thing is, I have never seen any commercialized instrumental model for the pyrolysis setup. So that's why I have asked like that, sir.
So maybe, sorry, what you do, Shiva sir, that you can go through one company that is Green Eco Solutions. So that company have a pyrolysis setup, and they are producing good amount of biochar from the different types of agriculture waste. So you will get more idea in terms of what type of pyrolysis they are using, and what are the main criteria which is required in terms of the pyrolysis are concerned.
Okay, sir. Thank you, sir.
Yes.
The company name is Green Eco Solutions.
Yes, Green Eco Solution. Maybe I'll also email you if if you just email me on my email address, I will definitely forward you the details about that company.
Sure, sir. Thank you very much.
Thank you.
Okay, I think if there's no questions, then we thanks Dr. Jain. Very interesting lecture, and many things he has told about the solid waste, and mainly about the organic waste and its composting methods. And whatever the problems in India, what is that also he has told. So beautiful explanations of all these things with the videos and everything. So we are very much thankful to Professor Jain. Thank you once again.
Yes, sir. Thank you, sir, and thank you all GEC family for this particular opportunity in terms of interaction with all the participants. Really, thank you. Okay, so I'll take a leave, sir. Okay.
Yes, yes. So participants, this is the end of session 1. We will be meeting in session 2 at 1 p.m.
ओके सर, तो मीटिंग एंड करता हूँ.
Yes, you can.
ओके, थैंक यू.